Scientists have achieved nuclear fusion. What does this mean for the future? The future of humanity has just become a little brighter. Scientists have achieved the impossible. They've unlocked the power of the stars right here on Earth. For the first time ever, they've successfully reproduced the process of nuclear fusion in a lab, opening the door to limitless clean energy. Will Elon Musk's dream of humanity becoming an interplanetary species finally come to fruition? What does this breakthrough mean for us and our planet? On the simplest level, nuclear fusion is when two atoms combine to create a heavier atom. This is the process that led to the elements heavier than hydrogen to be created within the universe's nuclear fusion powerhouses of stars. Inside the heart of stellar bodies, hydrogen atoms fuse together to create helium atoms. Then helium atoms fuse to create carbon atoms. This process continues on and on to create many of the heavier elements. When two atoms fuse to create a heavier atom, the resulting atom is always slightly less massive than the two original atoms added together. This missing mass is released in the form of energy, and looking at Einstein's famous equation E equals mc squared, we can see that the mass is multiplied by the speed of light squared, which is approximately 9 with 16 zeros behind it, which means a tiny bit of mass is equivalent to an absolutely enormous amount of energy. And now, scientists have been able to reproduce this stellar process inside of a lab to achieve net positive nuclear fusion. Ever since its first introduction into the scientific community in the 1950s, scientists have been trying to figure out how to use nuclear fusion to generate energy. Now, a team working at the U.S. National Ignition Facility in California were able to achieve nuclear fusion, in which they received more energy than they put in, making it a net positive energy gain for the first time. During their nuclear fusion experiment, the team was able to produce 3.15 megajoules of energy, while only using 2.05 megajoules to power the experiment. This gave them an output of 120% of the input. In order to get the atoms to smash together, the laboratory was set up to fire some of the most powerful lasers available to them, in order to energize a pellet of hydrogen plasma in order to trigger atoms into undergoing nuclear fusion. Now that net positive nuclear fusion has been achieved, the researchers are now on a quest to refine and improve their process to try and achieve the ultimate goal in this field: sustained nuclear fusion. Within the sun and stars in the sky, sustained nuclear fusion is the process that keeps their engines burning. When hydrogen atoms fuse together in the core of the sun, enough energy is produced from that process to cause more atoms to undergo fusion, creating a chain reaction where no more input energy is required to keep the process going. There are a number of challenges that scientists will have to overcome before they can achieve this. Sustained nuclear fusion can only occur as long as there is fuel remaining and enough energy is contained within the system. If they cannot find a way to contain the process within a specific volume, the energy produced will bleed out of the system, making this entire process fizzle out. If scientists can achieve sustained nuclear fusion, it will give humanity essentially an endless supply of clean energy. Think about how that would change the way that our society works if energy is freely available for anyone to use. Society could then turn their focus from generating enough energy to keep our world working and begin working on more matters that can help humanity. One of the large setbacks that space agencies have had in designing rocket engines that can cut travel time down significantly is the source of energy and fuel they can use. Modern rockets can only go so fast because of the efficiency they can achieve when burning chemical rocket fuel in order to generate thrust. And based on the current projections, this will not change at least for the initial steps of spaceflight. Chemical fuel will still be needed to get the spacecraft out of the Earth's atmosphere due to their unmatched thrust generation. But if scientists were able to utilize a sustained nuclear fusion reaction on board of a spacecraft, that energy could be used to power extremely efficient engines that will be able to sustain a constant thrust to accelerate crafts through space. Currently, nuclear engines that have been designed use nuclear fission as a power source, but adapting them to utilize a source of nuclear fusion would greatly increase their efficiency and power. While nuclear engines of today generate less thrust than traditional chemical fuel, they can provide continual thrust for a much longer time while using up much less material as fuel. There are several types of fusion engines that have been in development ever since the question of obtaining nuclear fusion in a lab became a question of when and not if. One of the most promising fission-driven rockets, called a nuclear electric propulsion or NEP engine, uses thermal energy generated from a nuclear reactor and converts it into electric energy, which eliminates the need for a propellant, greatly reducing storage needs. The current designs of NEP rocket engines utilizing nuclear fission would already cut the travel time to Mars by at least 60%. And due to the nature of these engines, further trips would only allow the spacecraft to accelerate faster, making them even more efficient and faster the longer a spacecraft is traveling for. But now that nuclear fusion has been obtained, a new type of nuclear-powered rocket that blows all others out of the running may completely change the future of space travel. In order to become an interplanetary species, travel within our solar system would need to become commonplace. NASA scientists have been working on ways to capture and use the power of a sustained fusion reaction in order to generate thrust. The fusion-driven rocket, or FDR, is a new generation of engines in which the fusion source infuses its energy directly into the propellant, bypassing the need to convert the energy into electricity. This process would theoretically give the propellant an enormous exhaust velocity approaching 30 kilometers per second, possibly eliminating the need for chemical fuel to break free from Earth's gravitational pull. And because of the nature of the fusion-driven engine, there would be no significant physical interaction with the body of the rocket itself, greatly minimizing the amount of damage and reducing the amount of thermal energy it would receive. The development of this type of engine would revolutionize space travel, not only making it faster and more efficient, but also making it affordable, allowing virtually anyone to take a trip through space if they wanted to. Because of the amount of energy a reactor with sustained nuclear fusion would produce, future spacecrafts have a lot of room to grow in terms of power and speed. One researcher developing a nuclear fusion reactor small enough to fit in a spacecraft believes that with enough funding, the type of engines required to take us from planet to planet could be developed in less than 2 decades. These types of engines would also allow near unlimited energy to help power life support and other critical systems on board the spacecraft, without having to worry about additional power sources. Researchers have noted that current theoretical designs of fusion rockets would cut a trip to the moon down to a matter of hours, and trips to Mars and other planets down to mere months. Additionally, in the future, scientists may be able to advance this technology enough in order to create spacecrafts capable of interstellar travel. The closest star to us, Proxima Centauri, sits just under 4.25 light-years from Earth. And if scientists can create a craft capable of speeds of just a small percentage of the speed of light, sending a probe to this star would be possible within 1 generation. And there is no signs that fusion-driven rockets would stop there. Some scientists believe they could hold the answer to achieving science fiction levels of space travel at speeds faster than light. Thanks for watching. Do you think you would want to take a trip around the solar system if it would only take a few months? Or would you want to wait for a bigger trip to another star system? See you next time on Matter.